Good morning. Today we're going to continue our discussion of quadrilaterals. Remember, a quadrilateral is any four-sided polygon. Quad meaning four, lateral meaning sides. So four-sided polygon with four sides. And we talked about a parallelogram already. A parallelogram, kind of in the name, the opposite sides are parallel. So a quadrilateral with two sets of parallel sides, meaning this set is parallel and this set is parallel. And we talked about, because of the parallelogram, the opposite sides are parallel and congruent. So these two sides are congruent, these two sides are congruent. Consecutive angles are supplementary, meaning these two angles are supplementary, but these two angles are also supplementary. And these two angles are supplementary, and these two angles are supplementary. Consecutive means next to each other. So these two angles are next to each other, so they're supplementary. These two angles are next to each other. They're consecutive, so they are supplementary, which means opposite angles are congruent. These two angles are congruent, and these two angles are congruent. And we talked about how the diagonals bisect each other, cut each other in half. Okay? And a diagonal is a line segment from one vertice to any non-consecutive vertice. So a quadrilateral will always have two diagonals, here to here and here to here. Okay? All right, we're going to start our discussion today talking about a trapezoid. And a trapezoid is a quadrilateral with one set of parallel sides. Only one set of parallel sides. That was going to be my number one there. So I won't write that down, but the only thing we're going to tell you about a basic trapezoid, the only thing, it has two sets of consecutive supplementary, I'm going to write a little shortcut, supplementary angles. Has two sets of consecutive supplementary angles, and what we mean is that these two angles are supplementary and these two angles are supplementary. Okay? We'll call this angle A and angle B. So angle A plus angle B equals 180. And we'll call this angle C and angle D. Angle C plus angle D equals 180 degrees. But these two are in a relationship. They have 180, and these two add up to 180, but there's no relationship across that. We can't say anything about angle B and C. We can't say anything about angle A and D. We can't say anything about angle A and C, or D and B for that matter. Okay? All right. And the formula for area of a trapezoid is pretty easy. Area equals, kind of like a triangle, 1/2 base 1 plus base 2 times the height. All right, now when we talk about bases, bases doesn't mean bottom, okay? This is our base 1 and base 2. It really doesn't matter. I'll call this base 1 and base 2. Okay? Now how does that work? Why does that work? Okay? What we're really saying is sometimes people will write it this way. They'll write it area equals base 1 plus base 2 times the height divided by 2. You'll see it like that sometimes. And what we're basically saying is the average of the two bases. You add the two bases, divide by 2. So the average of the bases times the height. Okay, let me show you why. I made up a couple of trapezoids today. These two sides are parallel, and what we're going to do here is we're going to take each of these little lines here as 1 inch. So 1, 2, 3, 4, 5, 6 inches on the bottom and 2 inches on top. Okay? So if we add the two bases together, 6 plus 2 is 8, divided by 2 is 4. So what we basically end up with, when we take the average of the two bases, what we end up with is the average of the bases, okay? I'm I'm going to call that just lowercase b, the average of the bases times the height. Okay? If you think of lowercase b equals the average of the bases, let me show you why that works. If I find my scissors here, and what I can do is cut off that section, and I cut off this section, and I can put that right there. And if I get that guy, and I put him right here, what we end up with is a rectangle that is 4 by 2. And 4 times 2 is 8. Okay? 4 times 2 is 8. So the area of the rectangle is 4 times 2 or 8. And we can take this guy and we can put him back there. And we can take this guy and put him back over here. And we have our trapezoid again. And that's why we're able to average the two bases. 2 plus 6 is 8. 8 divided by 2 is 4, because we can turn any trapezoid into a rectangle. Just to prove it, I have one more here. There's another trapezoid. This length right here is 3 inches, and this length is 1 inch. So what I'm going to do is I'm going to cut off half of the inch right here. This is 3 inches, so I cut off 1.5 inches. And my rectangle, before I cut it, my trapezoid had the same 2 inches by 6 inches, which again was an average of 4 inches. And if I take my two triangles that I just cut off and put them on there, I'm back to a average of 4. 6 plus 2 divided by 2 is 4. Now we have a rectangle 4 by, I believe I made it 1.5 inches. So the point is, we can take any trapezoid and turn it into a rectangle by averaging the bases. And we'll do some examples of that in a minute. The other trapezoid we're going to talk about is, or excuse me, the other quadrilateral we're going to talk about is a kite. A kite is a quadrilateral with two sets of adjacent congruent sides, but no opposite sides are congruent. So what we're saying is these two are adjacent, they're next to each other, and they're congruent, and these two guys are adjacent and they're congruent. Okay? So a couple other things we can add is that in a kite, the diagonals are congruent, or excuse me, are not congruent, are perpendicular. On a kite, one diagonal is bisected. One diagonal is bisected, and one set of congruent angles. Okay. So in a kite, the congruent angles will always be the two angles between the non-congruent sides. So these angles will always be congruent in a kite. And if we draw the diagonals in, we know that these two diagonals are congruent, or excuse me, perpendicular, and these two are bisected. So we know quite a bit about a kite as well. All right, now how do we find the area of a kite? To find the area of the kite, it is simply area equals 1/2 diagonal 1 times diagonal 2. It's diagonal 1 and diagonal 2. Alright, well, here's a kite, and I can't really remember the length. I believe I made it 3 inches. Yes. So this guy is 2 inches long from here to here, and this is 1 inch long. Oops, gotta look at my eye in there. And this guy happens to be 1 inch, and this guy is 1 inch. So you'll notice that these two guys are bisected, so it's actually 2 inches by 3 inches. So we have a kite that is 2 inches by 3 inches. So we could find the area by going 1/2 2 times 3. Well, 1/2 of 2 is 1, and 1 times 3 is 3, so the area equals 3. Or we could say 2 times 3 is 6, and half of 6 is 3, but the area is 3 cubic inches in this case, or I'm sorry, squared inches. Well, let me show you why that works. If we think of this as the rectangle, maybe I can move this and you can see this rectangle better. Okay. If we look at the rectangle, and it is 3 by 2, to find the area of the rectangle, we would go base times height. 3 times 2 is 6. Well, why is the kite half of that? And we basically went, if you think of the rectangle, base times height, but then we divide it by 2. And I think some of you can already see it. I can take these two corners and fold them down, and you can see that this triangle is just exactly equal to that triangle. And I can do the same here. Fold that down. So there's where part of my, well, I think I'm going to have to cut these to make them look better. If I cut these off, if I cut all the part that isn't a part of the kite off, you think you figured out. What I actually create is 2 identical kites. So when we're finding the area of the kite, we simply find the area of the rectangle it would create and divide it by 2, because the kite is half the area of the rectangle. It's not fitting perfectly. My drawing wasn't perfect, but you get the idea. Okay, so that is why area of a kite is 1/2 diagonal 1 times diagonal 2, because it is half of a rectangle with length of base, or diagonal 1 times the height of diagonal 2. Alright, I hope that helps. One last thing we're going to go over today is a rhombus. Okay, a rhombus is right down here, and a rhombus is a parallelogram with 4 congruent sides. The opposite sides are parallel. It has all the characteristics of a parallelogram, but it has 4 consecutive sides. And it's kind of like this. If you think of a rectangle, a rhombus like this, it is a parallelogram that these two sides, opposite sides, are always forced to be parallel, but it has 4 congruent sides, and we can move it around like that. That's a parallelogram and a rhombus, and we can squeeze it, and that's a parallelogram and a rhombus. And of course, if we force this rhombus to have 4 right angles, then we simply have what is a square. So a rhombus is just a parallelogram with 4 congruent sides, and a rhombus, or I should say a square, is simply a rhombus with 4 right angles, and a rhombus is just a parallelogram with 4 congruent sides. And we might as well take a look at a rectangle while we're there. A rectangle is just a parallelogram with 4 congruent 90-degree angles. Okay, so we'll probably get into a little bit more of those. So what do we know about a rhombus? A rhombus has 4 congruent sides, has all the characteristics of a parallelogram, plus 4 congruent sides. And one more thing, the diagonals of a rhombus, like a kite, are perpendicular. So diagonals are perpendicular, and diagonals bisect the vertices. Means it cuts these angles in half. So these two angles are congruent, and because of a parallelogram, opposite angles are congruent, so these two angles are congruent. So we have 4 congruent angles. And we can say these two angles are congruent as well as these two angles. And our diagonals are perpendicular, but also our diagonals are bisected. So we got a lot of lines here. These two are congruent, and these two are congruent. So we know about everything there is to know about a rhombus. Okay, and a square has all of these characteristics and all of these characteristics plus 4 congruent angles, 90-degree angles. Okay, a rectangle has all of these characteristics plus it has 4 right angles, diagonals are congruent, because of the 4 right angles, this diagonal is congruent to this diagonal. Okay, and I think that's where we'll stop. Let's do a couple of examples off of worksheet 9.3, which is your assignment today. On your worksheet, it was assigned yesterday, but we're a little bit behind because of late packet pickup. All right, so we'll just do a couple off of here. So on the front, you can see these are all trapezoids. So we know to find the area of a trapezoid, it is 1/2 base 1 plus base 2 times the height. All right, so this one is area equals 1/2 base 1, which is 21, plus base 2, which is 15, times the height of 12. So area equals 1/2. 21 plus 15 is 36 times 12, which means area equals half of 36 is 18 times 12. Okay, 18 times 12 is, what is that, 216? Okay, let's do this one over here. We'll do number 6, and I'll leave the rest for you. All right, well, got to be careful here. So again, area equals 1/2 base 1 plus base 2 times the height. Well, area equals 1/2. Base 1 is right here, 7 centimeters, plus, don't say 4, because remember it's 7 plus 4, or 11. And the height is, oh, well, we got a little trick here. It says this angle, or this line, is 5. Well, that's not the height. That's not the height. The height is over here. So we have to do Pythagorean theorem. It's a right angle. So we can say a squared plus b squared equals c squared. So let's go over here and say h squared plus 4 squared, equals 5 squared, which means h squared plus 16 equals 25. We subtract 16 from both sides. We get h squared equals 9. We take the square root of both sides. We get h equals 3. So our height is 3. So area equals 1/2 18 times 3. Area equals 9 times 3. 1/2 of 18 is 9. So the area equals 27 centimeters squared. Okay? Now some of you might remember this doesn't look like it, but a 3, 4, 5 right triangle. It's one of the Pythagorean triples we've talked about. It's a 3, 4, 5 right triangle. If you recognize that, you don't have to do this. So a 3, 4, 5 right triangle is something to remember. Okay, let's see. Let's do one kite problem for you. All right. So let's see. Let's just go with this one. You remember the area of a kite is found by going 1/2 times diagonal 1 times diagonal 2. So area equals, we always have to do some adding when we do kites because this diagonal is 6 plus 6 or 12, and this diagonal is 3 plus 9 or 12. Okay, area equals 1/2 of 12 is 6, and 6 times 12 is 72 feet. All right, I'm going to leave the rest for you guys to work on. You guys have a great day. I hope everybody's doing well.